Time to introduce one of those mathematical concepts that will stick with you for a very, very long time, and that is the concept of a limit. This is a foundational idea for calculus, but it's something that we are going to use to help us find asymptotes. So here is our notation. Limit as x approaches infinity of 1 over x. So what this means basically is as x gets really, really big, what does this thing that comes after it get closer and closer to? So hopefully you're thinking, well, that becomes 0. What if I said, what's the limit as x goes to infinity of x squared? Well, there is no limit there because as x gets big, this gets really, really big also, and it continues getting bigger, so this has no limit. What's the limit as x approaches infinity of the number 2? Well, as x gets really, 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 really big, this stays the number 2. So that limit is equal to 2. What about the limit as x approaches infinity of 1 over x squared? Think about what that would be. Well, 1 over x squared, that is getting closer and closer and closer to 0 also. And for that matter, the limit as x approaches infinity of 1 over anything, x to any power, call it k, will equal 0. Or for that matter, any number. It could be 7 over x to the k, because this denominator is going to get really, 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 really big compared to the numerator, and it will get closer and closer to 0. So hopefully you're drawing the connection to horizontal asymptote is the value of y that the graph approaches as x goes to infinity. So let's apply this. So we want to graph this. And let's start out by finding the vertical asymptote. Vertical asymptote will be where the denominator equals 0. So 2x plus 1 equals 0. 2x equals negative 1. X is negative 1/2. Awesome. How about the x-intercept? X-intercept is where y equals 0, and with a rational function of this type, a fraction, that's where the numerator equals 0. So 3x minus 4 equals 0. 3x equals 4. X is 4/3. There is our x-intercept. Then let's talk y-intercept. Y-intercept is where x equals 0. So we have y equals, well, 3 times 0 minus 4 over 2 times 0 minus 1. So we have 0 minus 4, 0 minus 1, that's 4. So we have a vertical asymptote, an x-intercept, a y-intercept. Now let's talk the horizontal asymptote. So what we want to do is we want to find the limit as x approaches infinity of 3x minus 4 over 2x plus 1. And when we get more into calculus, we'll talk a lot more about limit properties, but what we can do is we can apply the limit to each term independently. But that's a problem because the limit as x goes to infinity of 3x, well, there is no limit. That gets bigger and bigger and bigger, so that doesn't help us. Here's the strategy that we use. When we're finding the horizontal asymptote, divide all terms, not just some, by the highest power of x. Then take limit. So what's the highest power of x here? Well, it's x to the first. So I'm going to divide all of the terms by x to the first. And then I'm going to simplify. The limit is still there. I have not taken the limit. I haven't looked at what each of these terms gets closer to. But now I have, well, 3x over x is x minus 4 over x, 2 plus 1 over x. Now look at what happens. As x gets really, really big, what does 4 over x get closer to? Well, that gets closer to 0. As x gets really, really big, what does 1 over x get closer to? It also gets closer to 0. And what do regular numbers get closer to? Well, as x gets huge, 3 stays 3. So 3 minus 0 is the numerator. As x gets really, really big, the number 2 stays the number 2, and the second term becomes 0. So this limit is 3 halves. Our horizontal asymptote is y equals 3 halves. Many of you have asked, well, how do I find the horizontal asymptote without graphing? This is how. You're almost always going to get your graphing calculator when you do this, but this is where we get the horizontal asymptote from an algebraic standpoint. So let's sketch our graph real quick, then we're going to be done. So negative 1/2 is our vertical asymptote. Right there, x equals negative 1/2. Y equals 3 halves, that's 1.5. X-intercept is negative 1/2. Sorry, that's the vertical asymptote. X-intercept is 4/3. So that would be 1 1/3. That's right about there. Our y-intercept is 4. Sorry, not 4. Negative 4. I had a sign wrong over here. There should be plus 1. Hopefully you caught that. So negative 4. 1, 2, 3, 4. So our curve has to come from the asymptote down through these points. And these hyperbolas will always have branches in opposite quadrants. So we'll be able to sketch it in like that. So there, ladies and gentlemen, is this graph, completely drawn without the aid of any technology whatsoever. And as you get better and better and more awesome and awesomer, you too will be able to achieve this greatness.